Hey, pre-calculus, I got two examples for you for lesson 5.6. They're just slightly different from what you saw in 5.5, mainly being that we're going to be finding areas of triangles now. And two, this first example, it kind of draws out some faulty thinking in ourselves. So let's get to it. So first of all, the area of a triangle, as we all know, is half base times the height. Now, when you see this triangle, I think your genuine response is to say, easy. You drop a height from D to EF. So the height connects to the base. Height connects to or connects with? English is confusing. I'm going to go with. No, you connect to someone. You connect with someone. Two things connect. Height connects with base. Well, okay. I'll put a little asterisk next to it. So bottom line is, if we make D to EF, we could also do E to DF or F to DE. Okay, there's three options. Now, here's the thing. If we were to try to solve this right triangle, we just disrupted the one side we had. So now we've created at least one more variable. We've got one variable, we've got two variables, we've got three variables, now we've created a fourth one. And I think that we can do this without creating that fourth variable. And what it is saying, let's take away the obvious visual cue. So let's not make this the height. Let's make this the height. Now, it did split apart one of our angles. The 85 degrees is no longer 85 degrees. It's 90 minus 67 here. And then 85 minus 23 over here. Yeah, and I don't know if it's helpful to find D because I didn't say to solve for all the parts, but this is, for the record, 28 degrees. Even though it doesn't look like 28 degrees at all. Not drawn to scale. Wait, is that right? 28 degrees? I guess so, yeah. So now we've got this right triangle. The reason why that would be so much more helpful is because it retains one of its angles and it retains one of its sides. If that's the case, then we can solve for this, which also allows us to solve for that. And if we have the height here, we can use trig to solve for this. Boom, boom, boom. Those are the three parts we need in order to fill in for the base and the height. So that's H. I'm going to call this X, and I'm going to call this Y, where our base is going to equal X plus Y. All right, so let's get to it. Looks like the sine of 67 degrees is equal to height over hypotenuse, which is 54, and the cosine of 67 is equal to X divided by the hypotenuse. So right off the bat, we're going to find X and H. And then keep in mind, whatever H becomes, we can use that to solve for Y. So I'm just going to write out here right off the bat, if we take the tangent of whatever our height value is, I'll just call it H, that's got to be divided by Y. So these three triangles will be these three equations will be responsible for all the information we need to find the area. So if you multiply both sides by 54, you get H by itself. If you multiply both sides by 54, you get X by itself. And if you do the switcheroo here, Y is going to equal whatever H is divided by tan of 28 degrees. So let's do it. Which actually, you know what we can do right off the bat is we can say that h is equal to 54 sine of 67 degrees. So why don't we just plug it in right now? And yeah, 3 calculations. H equals 49.707. X equals 21.099. And then this right here equals 46.107. So, the area of our triangle here is 1/2 times the base, which is x plus y, x plus y, times the height, 49.707. So this is the part where if I was a sophisticated YouTube person, I would just fast forward. But we're definitely not there yet. Wow, that's a big area. It's 1,670.304. Area would be square units, square area, good way to remember that. So centimeters was our unit, so square centimeters. By the way, this was a totally different example than what we did in class, so if you're kind of confused, oh, I'm sorry. If you're kind of confused about that, if you were in class, just don't make it a big deal. Okay, this example was the one we did in class, so I'm going to move on to that one. We can all rally around that. So we've got a triangle with no angles. So there's 2 things I could ask you. I could say, find all the missing angles, or I could again say, find the area where you would have to find the height and one of the bases. Now we got all the potential bases, so that's not a problem. But finding the missing angles is going to be something entirely different. So, keep in mind that trig is only helpful if within the confines of a right triangle, and I'll bring you guys even closer here to the edge. Trig is only helpful if we have an angle or 2 sides of the right triangle. So, yeah, let's just split this right down the middle here. I'll call this H, but here's the interesting thing. You can avoid creating more variables than necessary by, instead of calling this X and Y, what you could do is say, let's let this one be X. But then let's say this here is going to be 85 minus X. Okay? 85 is the total minus X. Yeah, now we only have 2 variables and 2 right triangles. So it should be a lot easier to work with this way. Now, when you look at both the right triangles, I only have one side confirmed, the hypotenuses, no angles except the right angle, and we're not talking about, when we say one angle, we're not talking about the right angle there. So here's what we do. We don't use trig. We use the Pythagorean theorem. Check this. H squared plus 85 minus x squared equals 67 squared. We also have h squared plus x squared equals 71 squared. Okay, I've got 2 equations. I've got two unknowns. Now, if you recall back at least to Math 1 or Algebra 1, you could solve systems of equations using elimination or substitution method. This is going to be a little more complex than that, but not really. I mean, I could do substitution right away if I wanted to, or elimination. Elimination is if you can add or subtract to slice away one of the variables, then you can create a new equation that, if solved, yields the actual value that we're looking for to where these two equations intersect. What I mean by that is, if you subtract the columns, if the variables are lined up, the h squareds cancel. And then you're left with 85 minus x squared minus x squared equals 67 squared minus 71 squared. I think this is an equation we can solve. Okay? I showed in class how you could use substitution by subtracting this, okay, and then subtracting this. If they both equal h squared, they both equal each other. So there would be a similar equation. The algebra is going to come out the same at the end, so don't worry if you're watching this and you didn't see the in-class video. Both of them get us to our destination. So if you were to square this, remember there's a shortcut. You square the first, square the last, which the negative gets canceled out and becomes a positive, and then you double the product, not squared. You just double the product. So negative 170x. That's what this polynomial expands out to. And then you got this minus x squared here. Well, that's convenient. Looks like we don't have to deal with any quadratic formula. And then you got 67 squared minus 72 squared. If you want to, you can actually calculate these, whatever 67 squared is. I'm just saying maybe we can hold off on that until the very end. See, this is a constant. And then you've got negative 170x equals whatever these come out to be, and then you're dividing by negative 170. So you can kind of like save all the calculations for one stop on the calculator. If you are not comfy with that kind of calculator strategy, then by all means, figure out what the numbers are before you continue on the problem. Figure out what 67. I'm just throwing it out there. That might be a strategy that you haven't thought of. And I won't take it personally if you don't employ that strategy. The answer is x equals approximately 45.747. Now, all that work gave us just x. So, oh, wow. But in knowing that x value, we in turn can find this one. You're just taking it now away from 85, 39.253. So we found our base. Our base is 39.253 plus 45.747. The base of this triangle is... Oh, wait, we already knew it was 85. Whoops. Okay, so that was my fault. 85. We really only needed to solve for h. But here's the thing. It would have been most helpful, easiest to get x by itself anyway. So my thinking is you probably would have wanted to find the x first so that the h could be easier to solve for. So what I mean is, here's an equation for h. If I have x, where is it? There it is. This will be the more convenient way of getting h by itself. So subtract that from both sides. and then square root it. So it's the square root of 71 squared minus 45.747 squared. All right, we've got our height, we've got our base, the area of this triangle. Sorry, we're cramping space here. Oi. It's 1/2 base height. So it's 2,307.623 square units. I'm not sure if I attached it. I didn't attach any units to it, so it's just whatever those square units would be. And that's all she wrote for this particular problem. Actually, I just asked to solve for the missing angles. So this would be the area of it. Man, guys, I'm screwing up left and right. Here's the thing, though. We're 16 minutes and 20 seconds into this thing. I'm not starting the video over. So here's what I'm going to do. I am now going to solve for all those missing angles, and I believe I have more than enough information to do so. So, I didn't ask to solve for the area, but I just kind of went with it. So here's the thing. I've got more than enough info to land this plane. So let's land it. I'm just going to chalk this up to COVID, so the mistakes that I'm making right now. So what could we do to solve for the missing angle A? Well, we know that the sine of A is equal to 54.297 divided by 67. If we do the inverse sine, we got ourselves an angle. So sine inverse of 54.297 over 67 is going to approximate our angle A. Similarly, we can do the same thing for angle B. Divide that by 71. Then you sine inverse that thing to get the measure of angle B. Approximately. And when I say A, I mean the measure of angle A. All right, and then lastly, if we're looking for the measure of angle C, you just take 180 minus the measure of angle A minus the measure of angle B, and that will equal the measure of angle C. So our calculators, don't fail us now, we're almost done. All right, first one is 54.135 degrees. Second one is 49.884 degrees. And then the last one, we're just subtracting the two knowns, is 75.981 degrees. All right. So my apologies for not, for kind of going in all sorts of directions there, but I hope that allows you to at least see the different strategies for, when you don't have any angles and you need to find angles. Or in the previous example, when it's like, hey, sometimes you don't just draw the obvious height. Sometimes the height has to come in sideways, and the guiding information is, can I keep a whole side? And can I keep one angle? If that's the case, then you want to go for it. All right, guys. Thanks for watching.